Okay, so I'm going to go through all of the materials for our first investigation where we're going to model how molecules move across dialysis tubing. So what I have here is some dialysis tubing, and it's been soaking in some deionized water. This is made of cellulose. Cellulose is a carbohydrate, so it's a polysaccharide. And you notice I'm moving my fingers back and forth because this is how we can open the dialysis tubing, by moving our fingers back and forth underneath the water. So here's my dialysis tubing right here sitting in deionized water. I also have some string, so I can cut some string and then tie off my dialysis tubing. And then what I'm putting in the dialysis tubing is a solution of glucose and starch that I made last year. So it's a 7.5% glucose solution and a 1% starch solution. Glucose, remember, is a monosaccharide, so it's a simple sugar, it's blood sugar. And then starch is also a carbohydrate, but it's a huge carbohydrate. It's a large polysaccharide, and that's how plants store carbohydrates often is in starch in their roots. So the last thing I have, some deionized water, and then I have Benedict's solution, and I'm going to use this to test for glucose. And I have potassium iodide in this amber bottle, and this will allow me to test for starch. So first thing I need to do is just set up my experiment. So I'm going to take this dialysis tubing, and notice that I'm able to open this end, and this end's kind of difficult to open. So I'm going to just set it on a paper towel, kind of dry it off a little bit, and I'm going to get some string, get some scissors, and I'm going to cut some string, and I'm going to tie off the end that's difficult for me to open. Usually I have a partner, so one person can hold the tubing and the other person can tie, but I'm all by myself. So I'm just trying to tie it very tightly because I'm going to pour in my glucose starch solution into this dialysis tubing, and I don't want any of it to escape. Okay, that looks pretty good to me. So I'm just going to cut off the excess string. And now I have dialysis tubing with one end that's open and the other end that's closed. So this is some of that glucose and starch solution that I had prepared before. And instead of just pouring it into this dialysis tubing because it's kind of messy, I'm going to take a transfer pipette and I'm going to try to get this started and pour in some of this solution. I have a total of 15 milliliters that I'm adding to this dialysis tubing. And then sometimes you need a funnel, but I think I'll be okay without making a mess. And I have all 15 milliliters of that glucose starch solution in my dialysis tubing. So an important thing here is that I'm going to tie off at the top, and I'm giving it a lot of room because I want to see how molecules will move in and out of the dialysis tubing, and if I tie it off too tight, I don't have room for those molecules to enter because of the pressure of the tubing. So getting some more string, I'm going to tie off the top of my tubing. So hopefully I've tied that off pretty well. And now I have my glucose and starch solution inside my dialysis tubing. So I was trying to be pretty careful to make sure that I didn't spill any of those liquids anywhere on the outside of my dialysis tubing. However, just to ensure that I did not inadvertently get any of that solution on the outside of the bag, I'm just going to dip this back into this deionized water that my dialysis tubing was soaking in before I started this video, just to cleanse off any of the solution if I accidentally got it on the outside of the bag. And then I'm going to just gently pat this bag dry. To get off any of that water that's on the outside, just very gently. So the next thing I'm going to do is I'm going to take the mass of this dialysis tubing with the string and all of the liquid inside, and I've gone ahead and I've already put a weigh boat on my balance and tared it. And then what you're going to put in your data table now is a mass of 16.57 grams. So that's the initial mass of my dialysis tubing, is 16.57 grams. Now that that's all set, here I have just a plain old 400 ml beaker. I'm going to put some water in this beaker. It's not really super important the amount, but I'm going to put about 250 mils of water approximately into this beaker, and then I'm going to gently move my dialysis tubing into that beaker of water. And then what I'm going to place into this liquid surrounding my dialysis tubing is some potassium iodide solution. And a little bit more. And now you can kind of see some qualitative observations. The outside solution surrounding this dialysis bag is kind of like an amber yellow color. And then inside the bag is just a cloudy white solution. And then I'm going to place this over here and then just let that sit overnight. That part of my investigation is done, and I'm just going to let it sit. Now what I'm going to do is do some controls, because I want to see if water will cross through that dialysis tubing, and I also want to see if maybe that glucose or that starch can pass through that dialysis tubing. So I need a way to test for glucose, and I also need a way to test for starch. But more importantly, I need controls to make sure that my method is sound. So my positive control, and a positive control should always elicit a result. That's going to be the solution that I added to my dialysis tubing. So that's going to be my solution of glucose and starch. That's my positive control. My negative control should not give me a result, and my negative control is just deionized water, because there should be no carbohydrates at all in this deionized water. So I'm going to go ahead and I'm going to do the glucose test first. So what I'm going to do is if you see over here, I've labeled a few test tubes. One says positive, one says negative, and the other one is my sample. So I'm going to worry about this sample tomorrow, but I'm just going to do my positive and my negative test now. So I'm going to put about a milliliter of my positive control into the positive test tube. And I want about a milliliter, so I'm looking at this transfer pipette and it's graduated, so I can get a nice estimate and add about a milliliter of water, or a milliliter of my glucose starch solution. And then my negative control is water. So using a different transfer pipette, I'm going to put in about a milliliter of water. And then I'm going to add some Benedict's solution to both of these test tubes. Once that's done, I'm putting both of these into a water bath. So this is very close to boiling. It's going to probably start to boil very quickly, and I'm just going to let that sit there for at least 5 minutes, and then I'll wait and see my results. In the meantime, I can still go ahead and I can look at my starch test. So notice I still have a positive and a negative test tube for my starch test. So in my positive control will go my glucose starch solution, adding about a ml. And then my negative control is deionized water. I'm adding about a milliliter to that negative test tube. And then here we have the potassium iodide. And I'm going to add just a few drops of potassium iodide to each of these test tubes. So I did about 2 to 3 drops of potassium iodide to each of these test tubes. And then I'm just swirling so that you can see the difference in the color changes. So hopefully what you notice is that my positive control gives me this dark black or this deep purple color. And that's the reaction that I should get if starch is present. So potassium iodide, when added to a solution containing starch, should get this black kind of purpley dark color. And then when I do not have starch present, my negative control will be this soft yellow or amber color. So my starch test is done. Now, my carbohydrate test is almost, looks like it's finished too. It's had not quite 5 minutes, but I can still see a nice result. So this is the result that I should see if glucose is present. That's showing me that there's glucose there, kind of like a brownish or almost an orange color. If I leave it in there, I might even get a deeper orange color. And then my negative control still stays that original blue color of my Benedict solution. So now, when I come back tomorrow and look at my dialysis tubing and test for glucose or starch, I'm going to have things to compare that to. And then I'm going to go ahead and stop taping now, and we'll see what happens tomorrow.